Hello, ma'am.
Good evening, sir.
Hello. Good evening, ma'am.
Good evening, sir.
What, Ajay? Enjoying life? Huh?
No, sir.
No, sir. Hello. You didn't treat me for my birthday. No gift for my birthday. Yesterday, I saw you somewhere in Kamanali. Huh?
Sir, yes, sir. You went out for dinner.
So you forgot me.
Sir, you could have come, sir.
You didn't call me, man.
Sir, it was very late, sir.
Very late, huh? Yeah.
Yes, sir. We took question at last minute.
Give me a minute. I'll come back. Oh, wow.
Yes, sir.
Yeah. Shall we start? Is anybody else joining or only? Yeah. Okay. Last class, if you remember, we learned the rules for naming the coordination compounds. Briefly, I will tell you so that we can start naming the compounds and then we'll continue with the other part of the topic today. All right. Now the rules for naming the coordination compound. The first is we have to name the cation. Cation is a positive ion, followed by anion. The second point is if the cation is a complex, or whether you're naming the cation or an anion, you are supposed to name ligands first. Now, if it is a different types of ligands, you have to name it according to alphabetical order. And you have to give prefixes, di, tri, tetra, etc. And if the ligand contains a prefix, now for an example, ethane 1,2 diamine. Now it is abbreviated as EN. This ethane diamine itself contains a ligand, what's the prefix? So therefore, special types of prefixes we'll give. What are the special type of prefix? For 2, it is bis. For 3, it is tris. And for 4, tetrakis, pentakis, it goes on. Special type of ligands. And if we are talking about an anionic complex, the name of the metal has to end with ATE. Ferrate, mercurate, nickelate, chromate, all that. The name of the metal has to end with. For a metal in the cationic complex, it will have the same name. And you should write the oxidation number of metal in brackets. Oxidation number of metal. Last class, I remember, I taught you how to find the oxidation number of few of the complexes. Anyways, no time for all that now again. Now we'll directly start with naming of some of the compounds. While naming some of the compounds, we will try to understand how to find the oxidation number, all that. All right.
Yes, sir.
Now, few compounds we'll try to name, and I've given you the detailed the steps which we have to follow to name the coordination compound in the last class. Now, just for the continuation sake, revision sake, I just explained a few points. Anyways, we'll continue with naming the coordination compound. Now, just observe the first compound. It is CONH3 6 times Cl3. Now, I told you last class, when you're naming the coordination compound, you have to know the different types of ligands. When we say different types of ligand, you should know what type of ligand, whether it's monodentate, bidentate, tridentate, polydentate, whether it's cationic ligand, positive ligand, negative ligand, or ligand, all that you should know. Anyways, now we'll start with the first example. In order to find the first name the first example Cu 6 times Cl3. The first step is we'll try to find the oxidation number of the central metal. So whatever metal is present in the complex square bracket, it is called a central metal. Here, cobalt is the central metal. We'll find the charge on the cobalt. Now, how do I find the charge on the cobalt? As a whole, the complex is having neutral charge, 0. We know chlorine is a negative ion, Cl minus. Cl minus, when we say it is -1. -1 into 3 is -3. Ammonia is a neutral ligand. Ammonia is a neutral ligand. It is having charge 0. 0 into 6 is 0. Cobalt, we are finding out. We take it as X. So X will be equal to +3. Oxidation number of cobalt is +3. We have found out the oxidation number of cobalt. Did you understand this? Now, the next point is, if you see, whatever is outside the square bracket is called as a counter ion. Whatever is outside the square bracket is called as a counter ion. This counter ion is negative. When we say counter ion is negative, the complex is a positive ion. It's a cation. So the rule says first you have to name the cation. In order to name the cation, this cation is a complex. Since it is a complex, you have to name the ligand first. Now, we have ammonia. 6 we have. Therefore, it is hexa. 6 stands for hexa prefix. Ammonia has a special name. It is a neutral ligand. It is named as AMMINE. AMMINE, hexaamine. Cobalt. It's all one name, no space. Cobalt is a central metal. Cobalt. What is the? See, it's a cation. Since it is a cation, the charge on cobalt, the name of the metal will write as cobalt itself. And what is the oxidation number of cobalt? It is 3. We have to write the. And then once you have named the cation, you have to name the anion. The anion is chloride here. Will I write trichloride or will I write only chloride? For counter ions, there is no prefixes. For counter ion, there is no prefixes. Therefore, we will write only chloride. So what will be the name of this complex? The name of this complex is hexaamine cobalt 3 chloride. Did you follow this?
Yes, sir.
Yes, sir.
The second example is AgNH3 twice Cl2. Now find out the oxidation number of silver. The oxidation number of silver, what will be the oxidation number? Chlorine, as a whole, the charge on the complex is 0. As a whole, the charge on the complex is 0. Chlorine is -1. Ammonia is a neutral ligand. 0 into 2 is 0. Silver, we are finding out. Central metal is silver, X. So X will be equal to +1. So oxidation number of metal is +1. Don't memorize the oxidation numbers. Find out the oxidation numbers. Now again, you can see the counter ion is negative. Since the counter ion is negative, we understand the complex is positive. And complex which is positive contains a ligand. What is this ligand? Ammonia. How many we have? 2. So therefore, it is diamine. Diamine, 2 double M. Diamine. Silver. And oxidation number of silver is 1. Silver, and the name of, we'll complete it with the anion. It is chloride. So diamine, silver 1, chloride. Followed?
Yes, sir.
Yes, sir.
The next example, we have FeCO 5 times. As a whole, this complex is 0. Carbon monoxide is a ligand. When carbon monoxide is a neutral ligand. Carbon monoxide, nitric oxide, NO, water, ammonia, they are all neutral ligands. Here, carbon monoxide is a neutral ligand. 0 into 5 is 0. So iron, we don't know, we take it as X, so X will be 0. Here, the oxidation number of iron is 0. When oxidation number of iron is 0, and we know that it is a neutral complex. It's a neutral complex. So how do I name this? The ligand is carbonyl. So we have penta. Carbon monoxide has a special name. It is called as carbonyl. Pentacarbonyl. Iron. Oxidation number of iron is 0. You have to write it in brackets. The oxidation number of iron to be 0. So penta, all is one word. There is no space. There is no space. It is appearing to be one word. Followed?
Yes, sir.
The next example. Am I fast or are you able to follow? See, we have to learn many examples. Today, at least we'll finish up with the naming part. We have to go for the next topic. This is a big chapter again. All right, organic chemistry have to start possibly after this chapter. Now, the next example, what we have is KPtCl5, and we have ammonia. Now, clearly we understand the counter ion is positive. So complex will be what? Negative. This is negative. The complex is negative. So what is the charge on the complex metal, central metal? As a whole, the charge is 0. Ammonia is a neutral ligand. Chlorine, what is the charge? What is the charge on chlorine?
So -1.
-1 into 5 is how much? -5.
-5.
Platinum, we don't know. We take it as X. And potassium, what is the charge? It's a first group metal. So potassium is K+1. So X will be equal to what now? +4. The charge on platinum is 4. Now, how do I name this? First, what I will name? Potassium, because potassium is a cation. Potassium. Now, here we have two types of ligands, ammonia and chlorine. When we have different types of ligands in a complex, we have to name according to the alphabetical order. So it will be potassium. Ammonia is named as what? Amine. Amine, special name. It's a neutral ligand, amine. And we have now pentachlorido. See, when chlorine is a counter ion, we write it as chloride. When chlorine is a ligand, we write it as what? Chlorido. Because all negative ligands, the name has to end with what? O. Pentachlorido. Then what's the metal we have? The metal is platinum. The metal is platinum. So we write it as platinum or platinate, I will write. See, this is an anionic complex. In anionic complex, the name of the metal has to end with what? AT. Platinate. What is the oxidation number of platinum? We found out the oxidation number of platinum to be 4. So we write it as 4. Did you understand why I'm writing platinate?
Excuse me,
Yeah.
sir.
Yes, yes.
Sir,
Yeah.
oxidation number should be right in Roman numbers.
Roman. Yes. All are in Roman. All are in
Yes,
Roman. All right. All are in Roman. Okay. The next example, K3FeC2O4 What is this? K3, we have FeC2O4 and 3. What is the C2O4? What is the C2O4?
Sir, is it oxalate, sir?
It's an
Oxalator?
oxalato ion. It's an oxalato ion.
Oxalator.
What is the denticity of oxalato? It is a monodentate
Sir,
or bidentate?
Bidentate, sir.
It is a bidentate. Whether it's neutral or negative?
Sir, it's negative, sir.
Negative. So oxalato is a bidentate ligand, -2. -2 into 3 is how much? -6. Iron,
-6.
we don't know. I take it as X. Potassium is +1. +1 into 3 is 3. So X will be equal to what? +3. So oxidation number of iron here is +3. So what will be the name? See, potassium is a cation and complex is an anion here. So will I write 3 potassium or I will write only potassium? I will write only potassium. Potassium, I will not give the prefix potassium. And I have 3 oxalato. Since we have 3 oxalato, we write it as trioxalato. Iron has a special name because it's anionic complex. The name has to end with ATE. So it is named as ferrate. Ferrum means it is iron in Greek or other language. So it has to be named as ferrate. You will not name it as iron. See, here we named it as iron. It's a neutral complex. We name it as iron. In a cationic complex, the name will be what? Iron. But in an anionic complex, iron will have the name ferrate. What is the charge on ferrate, iron? We found out it to be 3. So we write it as what? 3. Potassium trioxalato ferrate. Did you follow?
Yes, sir.
Yes, sir.
Now just observe this example. This example as a whole, The charge on this is 0. Nitrite ion is NO3 minus, -1. Ammonia is a neutral ligand, 0 into 4 is 0. NO2, nitrito, it's a NO2 minus it is. So nitrito, it is -1. Chlorine is again -1. Cobalt, we take it as X. So X will be equal to +3. Oxidation number of cobalt here is +3. Now it is a cationic complex. And this is an anion. So complex has to be named first. So we have 3 different ligands. Ammonia we have, nitrito we have, chlorine we have. So we have to name according to the alphabetical order. So it will be tetraamine, because we have 4 ammonia. A comes first, tetraamine. Then we have chlorido. And then we have nitrito, Nitrito, nitrito. This nitrito, what is the donor atom? Nitrito is an ambidentate ligand. We learned lastly, NO2 minus, or we can write it as what? ONO minus. So here it is nitrogen is the donor atom. Here it is oxygen. So here, as per the understanding, here the donor atom is nitrogen. So therefore, we will write it as N. N cobalt. N cobalt, metal is cobalt, and oxidation state of cobalt is 3. And the counter ion is nitrate. So cobalt 3, nitrate. Since I didn't have a place, I've written it down. So see the length of the naming. It depends on the number of different types of ligands present in the complex. If you have more number of ligands in the complex types, then the length of the name becomes what? More. Did you follow this?
Yes, sir.
The next one, see, this is a complex. It's an ionic complex. It's a complex ion. We have to name the complex ion. So the charge, you can see it is plus. It is +1. Charge is +1. That will be equal to En is a neutral ligand. Neutral ligand. En, ethylene diamine is a neutral ligand. So 0 into 2 is 0. Plus, here you can see ONO minus, nitrito, this -1. And chloride is -1. Cobalt is what? X. So X will be equal to what? +3. Charge on cobalt is +3. Here the charge on cobalt is +3. So what will be the name of this? It is a cationic complex. Since it is a cationic complex, only ion is given there. So we will try to name this. First is chlorine. C comes before E and E comes before N. So first we have to name chlorine. It is called as chlorido. Ethylene diamine. Ethylene diamine. The name itself contains what? A prefix. Therefore, we have to give a special prefix, bis. After you give a special prefix, you give a bracket. We write it as what? Ethane 1,2 diamine. Ethane 1,2 diamine. Then we write nitrito. What nitrito here? It is getting bonded through oxygen. Therefore, I write it as what? O. What's the metal here? Cobalt. What's the oxidation state of cobalt? 3. And you see it is an ionic state. Therefore, you have to write it as ion. Chlorido, bis, ethane 1,2 diamine, nitrito, O, cobalt 3 ion. Did you follow this?
Yes, sir.
Yes, sir.
The next example. As a whole, this is a neutral complex. As a whole, the charge is 0. Oxalato, C2O4 is oxalato, don't forget. Oxalato is -2. -2 into 3 is -6. Aluminium, we don't know, we're trying to find X. And potassium is +1. +1 into 3 is 3. So X will be equal to +3. Now, what will be the name of this? So aluminium will have a charge +3. What will be the name of this molecule? The name of this molecule will be potassium. And now we have to name the anionic complex. So it is, 1 minute. Potassium and trioxalato. 1 minute, man. Trioxalato. We have 3, so we'll write it as trioxalato. Aluminate. Aluminate. Oh, what happened? Aluminate. Sorry, something, this writing is not okay. Aluminate. Negative. Metal is an anionic complex. So therefore the metal has to end with what? Ate. And the charge on aluminum is 3. So it is named as what? 3. Followed? Potassium trioxalato aluminate 3. Did you understand this?
Yes, sir.
Yes, sir.
Next example, that is Fe4 FeCN6 3 times. What is the charge on the ion here? The charge on the ion here is, as a whole, the charge is 0. As a whole, the charge is 0. And you can see FeCN6 thrice. So cyanide is a negative ligand. Minus 1 into 6 is minus 6. Minus 6 into 3, it is minus 18. And here it will be 3 ion atoms plus 3x. And plus here it is ferric ion. 3 into 4 is plus 12. So what will be that? 3x will be equal to what? 6. So x will be equal to plus 2. Did you understand how did I work out this?
Yes, sir.
Yeah?
Yes, sir.
Yeah. Now ion here has a charge plus 2. Here ion is having plus 3 charge, you should remember. Now this is plus 3 charge. How do I name this? This is named as ferric hexacyanido. Ferrate. The oxidation number of ion in the complex is what? Plus 2. So we name it as plus 2 like this. All right. The next one is PtCl2NH34 and PtCl4. Now remember, this is called as coordination isomerism. We have to learn something called as isomerism later. See, both cation and anion, both are complex. One is cation, the other one is anion. How do we name this? So here, the name will be tetraamine. 4 ammonia molecule we have. Tetraamine dichlorido platinum 4. Sorry, this is in Roman letter 4. And we have here tetrachlorido platinate. There's an anionic complex I told you, platinate, and oxidation number will be 2. See, here we have 2 chlorine. Therefore, for this complex, the oxidation number becomes 2. And here we have only 2 chlorine. For this complex, the oxidation number becomes 4. This kind of coordination, this kind of compounds are called as coordination isomerism. Coordination isomerism. Did you follow? Next, again, it's same. This is a cationic complex. It's an anionic complex. Here, this is a neutral ligand. Here, you can see chlorine was having 4 charge. Therefore, here platinum will share 2 positive charge, and here also will be 2. So how will I name this? This is tetraamine platinum 2, and here it is tetrachlorido cuprate. Why I'm writing cuprate? This is an anionic complex. So name of the metal has to end with AT, cuprate 2. All right. So the next example, this is NiDMG twice. This DMG is called as nickel dimethyl glyoximate. This dimethyl glyoximate will have oxidation number. It is a negatively charged ligand. Since it is a negatively charged ligand, it will have oxidation number 2. And you can see here, DMG stands for dimethyl glyoximate, I told you. The name itself contains what? A prefix di. Therefore, we have to give a special prefix bis. Dimethyl glyoximato. Glyoximato, because negative ligand, glyoximato. And nickel will have what charge I told you? 2. Because this is a monodentate negatively charged ligand. -1 into 2 is -2. Therefore, the oxidation number of nickel is 2. Followed?
Yes, sir.
Yes, sir.
Now someone name this molecule. Let's see. What's the oxidation state of iron here? Platinum. As a whole, the charge is 0. Chlorine is -2. Nitrate is -1. Ethylene diamine is neutral. Chlorine is -1. Ammonia is neutral. Therefore, platinum, we take it as X. So X will be equal to +4. Oxidation state of nickel, platinum is what? +4.
So plus
Now,
4.
yeah, tell me what will be the IUPAC name of this molecule. So this molecule, this we didn't learn, we will do it later. Now you tell me what will be the oxidation state. A comes first, amine, next is chlorine, third is ethylene diamine, fourth is nitro. So what will be the name? So it will be
So
diamine,
diamine,
chlorido,
chlorido,
then what? Chlorido,
ethylene diamine.
it's only, since we have only one ethylene diamine, no prefix. So
Yes, sir.
ethane, you write better.
Yes, sir.
Ethane,
Ethane,
1,2 diamine.
1,2
1,2 diamine. Then nitrito.
Yes, sir.
What
Nitrito.
nitrito? What
So
nitrito? Nitrogen is bonded.
nitrito. So
N.
nitrito N, sir.
N. So what
Nitrito
will-
N.
N, platinum.
Platinum, sir.
Platinum, what's the oxidation state of platinum we found?
4, sir.
4. And what is the name? Complete the name. It is chloride.
Chloride.
Did you follow? See the length of the name. Got it?
Yes, sir. Yes, sir.
Now this we didn't name. We will name it. We'll name this here. Now tell me what will be the oxidation state of mercury here. As a whole, the charge is 0. Chlorine is -1 into 4 is -4. Mercury is X. And potassium is +1. +1 into 2 is +2. So X will be equal to what? +2. The charge on mercury is +2. Now, what will be the name of this molecule? The name of this molecule is potassium tetrachlorido. Mercurate. Why do I name it as mercurate? Mercurate. Why mercurate? It's an anionic complex. The name has to end with what? ATE. Mercurate. What is the oxidation number? 2. Followed?
Yes, sir.
Now, the other examples, 1 or 2 more examples we have, we will learn that here. What's the name of this molecule? The charge on chromium is +3. You know how to find the charge. You do it. So it will be what? Dibromido, bis, ethane, 1,2 diamine, chromium. Metal is chromium here. Chromium. Oxidation state of chromium is 3. Chromium 3. And what will be the name of this? Bromide. Did you understand? Should I write the oxidation name again? How to find the oxidation name? Is it possible?
Yes, sir.
What will be the name of this one? It will be potassium cation. Yes, cyanide we have and nitro. This is neutral ligand. C comes before. Potassium pentacyanide nitrosyl. Neutral ligand. NO is a neutral ligand. Nitrosyl. And we will name ferrate. Oxidation number of iron here is minus. This CN is minus. No, -1 into 5 is -6. -5. This is a neutral ligand. NO is a neutral ligand. As a whole, the charge is 0. This NO is a neutral ligand. This is -1 into 5 is -5. And iron, we don't know. We take it as X, and
Sir.
potassium is 3. So X will be what? Plus 2.
Yes, sir.
Correct? 2. Yeah.
Yes, sir.
Did you follow? Same thing here also. What will be this? This will be sodium. Sodium pentacyanidO nitrosyl is a neutral ligand. NO is a neutral ligand. Nitrosyl ferrate. What's the oxidation number here? It will be 3 because this is -5, this is 0, and this is what? +2. So here it will be what? +3 oxidation state ion. Did you follow this? Students, you followed?
Yes, sir.
Yes, sir.
Others, are you there? Yeah. How many more are there in the class? Yes. Varsha and Ritika, are you following?
Yes, sir.
We'll go to the next part of the topic. The next part of the topic is isomerism. You need a lot of imagination. You need to understand this concept. It is easy. All right. Now, what are isomers? Now, when we say isomers, I will take an organic molecule and explain. Now, C2H5OH, this is alcohol, ethanol. And here it is CH3O and CH3. This is ether. This is the ether, dimethyl ether, and this is ethanol. Now, the molecular formula for both is C2H6O. Both contains 2 carbon atom, both contains 6 hydrogen atom, and both contains 1 oxygen atom. Now, this alcohol, ethanol, is used in the alcoholic beverages, drink. Now, this ether cannot be used for drinking purpose. Now, both contain same molecular formula, but the physical property and chemical property will be different. When I say physical property, the melting point, the boiling point will be different. Surface, whatever that, viscosity will be different. Surface tension will be different. Okay, physical properties are what? Different. As well as the chemical property, the reactivities are different. So those kind of compounds are called as isomers. In simple way, can I say different molecules having same molecular formula as an isomer? Iso means what? Same. Mer stands for molecule. So molecules having same molecular compounds having same molecular formula, same molecular formula, but different physical and chemical properties are called as isomers. Did you understand? Or we can say different molecules having what? Same molecular formula can be called as what? An isomer. Did you follow? Sorry. Followed?
Yes, sir.
No response?
So followed, sir.
Followed, sir.
Followed, yeah. Now, even coordination compounds will exhibit isomerism. Compounds having same molecular formula, but different structure or spatial arrangement are called as isomers. And the phenomenon is referred to as isomerism. So what are isomers? Compounds having same molecular formula, but different structures or spatial arrangements or different chemical properties and physical properties are called as isomerism. Now, in organic chemistry, you would have learned isomerism is classified into two, structural isomerism and stereoisomerism. Now, we'll have to learn the structural isomerism first. So there are 8 types of structural isomerism. Coordination compound contains 8 types of structural isomerism. In organic chemistry, you would have learned chain isomerism, position isomerism, functional isomerism, metamerism. You would have learned in your 11th standard. But here it is not with organic chemistry, it is with coordination compound. So structural isomerism, there are 8 types of structural isomerism. But in our syllabus, we have only 4 to be learned. So first is ionization isomerism. Second is linkage isomerism. Third is solvate isomerism. Fourth is coordination isomerism. Likewise, when we come to stereoisomerism, in organic chemistry also we have 2 types of stereoisomerism. Even in coordination chemistry, we have 2 types of stereoisomerism. That is optical isomerism and geometrical isomerism. We will understand each and every type of isomerism in detail with examples. But you should remember, isomers are compounds having same molecular formula, but different physical and chemical properties. In coordination chemistry, we have coordination chemistry also, two types of isomerism. One is structural isomerism, the second one is stereoisomerism. Structural isomerism are 8 types. And now syllabus, we have only 4 types. What are those? Ionization, linkage, solvate, coordination isomerism, and geometrical isomerism and optical isomerism in case of stereoisomers. Now we will learn few, at least we will try to learn the structural isomerism possibly today. Structural isomers. Here the isomers have different arrangement of ligands around the central metal atom. It's of the following type. The first one is ionization isomerism. The first is called as ionization isomerism. What is this ionization isomerism? We will understand ionization isomerism little later. Now I will write CONH3 5 times, SO4 and Br. And we will write one more molecule, CONH3 5 times, Br and SO4. Now tell me, both the molecule contain how many cobalt atoms? 1. How many ammonia molecule it has? 5. How many sulfate ion it has? 1. How many bromine atom it has? 1. Each has what? Same. So that means for both the molecules, the molecular formula is same or not?
Yes, sir.
For both the molecules, the molecular formula is the same. Now, we're talking about ionization isomerism. When this is dissolved in water, this will dissociate to form CONH3 5 times, SO4 and Br minus. So here it will be the charge plus. This will dissociate to form CONH3 5 times, Br plus SO4 2 minus. Sulfate ion, the charge is -2. Here the charge is +2. Did you understand? Did you understand this?
Yes, sir.
Yes, sir.
Now this is the example for ionization isomerism. What is this ionization isomerism? Compounds having same molecular formula. Compounds having same coordination, compounds having same molecular formula, but ionize to give different ions in solution. Those are called as ionization isomers. What is ionization isomerism? Coordination compounds having same molecular formula. See, these two have same molecular formula, but in solution in water, they ionize to give different ions. See, this is a different ion which contains sulfate. This is a different ion which contains bromide. And you can see the simple ions are here, bromine, and here it is what? SO4 2 minus. Did you understand?
Yes, sir.
Now see the definition. Definition is clearly mentioned here. Coordination compounds having same molecular formula but gives different ions in solution are called as ionization isomers. Coordination compounds having same molecular formula but different ions when dissolved in water, or they give different ions in solution. They are called as what? Ionization isomers. Followed?
Yes, sir.
Yeah, there are examples. Here they have given examples. See, the same example what I gave you, what only is mentioned here. All right, a sulfate ion in the ionization sphere. Sulfate ion is a counter ion. Here bromine is a counter ion. This will react with barium chloride to give white precipitate because sulfate ion is free. Here, which will not react with barium chloride because sulfate ion is in the ligand. So, but it will react with what? Silver nitrate to give a pale yellow precipitate of silver bromide. Pale yellow precipitate of silver bromide. Did you understand this? So, whatever ions is present in the complex, it will not react as an individual ion. Whatever is outside the square bracket, they can react as individual ions and they can give you a separate or specific test. Followed?
Yes, sir.
Now, second type is we are learning coordination isomerism later. Right? Today we'll finish off these 4 kinds of isomerism. Linkage isomerism. Can you see the screen?
Yes, sir.
Linkage isomerism we will learn. See, what is the coordination number of cobalt here? We have 6 ligands here. This is ONO and 5. Totally 6. Whenever the coordination number is 6, it will have octahedral complex. It will have what structure? Octahedral structure. Octahedral structure means you can see if you have a book with you, you can take the book and hold it horizontally, and 4 corners of the book, 4 ligands, 1 on the top and 1 at the bottom. So this is the book, 4 corners of the book, 4 and 1 above and 1 below. This is the structure octahedral. Now you can see here, I write ammonia here. Here also ammonia I will write. Here ammonia I will write. Here also I write ammonia. Here I write ammonia. Here we write it as ONO. This is a complex and we have Cl2. Now if I write for this molecule, it is again an octahedral complex. 6 ligands. So ammonia, here also ammonia, here also ammonia, ammonia, ammonia. Here it is NO2. And I will write Cl2. Now just observe here. In this case, this ligand is bonded through oxygen. For both, the molecular formula is same. Both contains 1 cobalt, 5 ammonia, 2 chlorine, and 1 NO2. 1 NO2. Molecular formula is same here. But here, in this case, it is bonded through oxygen, and here it is bonded through nitrogen. So this is an example for ambidentate ligand. So whenever ambidentate ligands are involved, then the isomerism which is formed is called as linkage isomerism. What is this linkage isomerism now? Compounds having same molecular formula, same structure, but differ in the mode of linkage to the central metal atom. Here it is linked through what? In this case, it is linked through what? Oxygen. Here it is linked through what? Nitrogen. So when the linkage of the central metal atom, a ligand to the central metal atom is different, then we call those kind of isomers as what isomers? Linkage isomer. What do you mean by linkage isomers? Compounds having same molecular formula, but they differ in this bonding to the central metal atom or attachment to the central metal atom. You can see here, linkage isomerism. In this case, isomer differ in the mode of attachment of ligand to the central metal atom. And the phenomenon is called as linkage isomerism. So ligand, when they attach to the central metal atom or the different state, then it is called as a linkage isomerism. We followed with linkage isomerism, students?
Yes, sir.
Yes,
Others?
sir.
Yeah, example you have to give. Whenever they ask you for 2 marks, you write a statement and also example. Next is hydrate isomerism. Now I just write like this: CrH2O 6 times Cl3, and I'll write CrH2O 5 times Cl, Cl2 dot H2O. Tell me, in both the cases, the molecular formula is same or not? In both the cases, the molecular formula is same or not? How many chromium we have? 1 chromium in both the cases. How many water molecule you have? 6. Here also you can see 5 plus 1, 6. How many chlorine we have? 3 here. Here also we have 3. Is the molecular formula same?
Yes, sir.
Is the molecule? Yeah.
Yes, sir.
But here, how many water molecules behaving like ligand?
6, sir.
Here, how many is behaving like ligand?
5.
So hydrate stands for water. What do you mean by hydrate isomers? Isomers having same composition, but differ in the number of water molecules of the ligand. So molecular formula is same, structure is same, but the number of water molecules behaving like the ligands are different. Those are called as hydrate isomerism. You can see all these are examples for hydrate isomerism. Here you can see this This is bluish green in color, and here it is monohydrate here. See, this also you should know the naming of it. So what will be the naming of this? This will be hexa aqua. Water is named as aqua, neutral ligand. Chromium 3 cobalt. Chromium 3 cobalt. What's a chloride? Sorry, chloride. Here, what's the name of this molecule? It is penta aqua chlorido 5 chlorine 5 automatic chlorido chromium 3 chloride. But this water molecule is outside the bracket. So you have to write it as how many? 1 we have. Therefore, we have to name it as monohydrate. You understand?
Yes,
Students,
sir.
you followed. Now
Yes,
just
sir.
observe here. In this example, you can see here. Tetra aqua dichlorido, dichlorido, chromium, oxidation number is 3. And outside we have chlorine. Therefore, we write chloride. How many water molecules? We have 2 water molecules. Therefore, it's written as dihydrate. So when the water molecule is outside the water, this complex, it is named as hydrate. All right. Only in the ligand, it is named as aqua. Now, coming to coordination isomerism. What is coordination isomerism? See, these are the examples for coordination isomerism. Cobalt is a metal, chromium is a metal. Cobalt contains ammonia as a ligand, chromium contains cyanide as a ligand in the first case. In the second case, chromium has ammonia as a ligand and cobalt has cyanide. That means, now if I write like this, CO, NH3 6 times, and if I write Cr, Cn 6 times. Now, in order to write the isomerism, we'll write the definition CO. The cyanide will attack here. The ligands will interchange. So here we have chromium. Ammonia will go here. CF, NH3, 6 times. Now, what is the definition of coordination isomerism? In this case, compounds is made of cation and anion. So always coordination isomerism, both the complexes will be, both the ions will be complexes. It contains, in this case, compounds is made up of cation and anion. And the isomerism arises due to interchange of ligands between the complex cation and complex anion. Interchange of ligands between complex cation and complex anion. See, this is a cation, this is an anion. In the second case, you can see the ligands are what? Interchanged. Those kind of isomers are called as coordinate isomers. What do you mean by coordinate isomers? In this case, compounds is made of cation and anion. And the isomerism arises due to interchange of ligands between complex cation and complex anion. Did you follow?
Yes, sir.
Yes, sir.
Followed? Any clarifications you have? See, I cannot continue with the stereochemistry or stereoisomerism now. It is a different concept. Stereoisomerism is a different concept. It will take a lot of time. So it is a huge task. So it cannot be started today. So till now, what we have done with coordination chemistry, IUPAC nomenclature, or if you have learned with, we have learned with structural isomerism, 4 types of structural isomerism. One is ionization isomerism, second is linkage isomerism, third we learned hydrate isomerism, and fourth we learned coordination isomerism. Any confusion, any clarifications, please? Any clarification, students? You can ask me.
No, sir.
No clarification?
Sir, so once again you glance the rules for IUPAC naming, sir. Coordination compounds.
I have not typed. Okay, we'll see if it's there. I'll
Just
check.
the rules, sir.
I don't know whether we have. Yeah, see, so many rules were there. Okay, the first is the positive part of the coordination compound is named. Positive means cation, followed by a negative part. Negative part is anion. Now, if the ligands are named first for ligand, see if the complex we are naming, we have to name the ligands first. followed by the central metal. So I told you, in this case, no, maybe I'll write one example. K4FeCN6 we will write. Now this is an anionic complex. First you have to name the cation. What's the cation here? Potassium. So cations, counter ions will not have prefixes. We have named potassium. When you're naming the anion, you have to name the ligand first. Instead of naming the metal, you have to name the ligand first. So it will be hexacyanide. It's a monodentate ligand, and the name is cyanido because it's a negative ligand, cyanido. After you name the ligand, see, you have to give prefixes, di, tri, tetra, etc. So I gave you hexacyanido, I gave. Once you have named with the ligand, then you have to name the metal. Since it is an anionic complex, the name of the metal has to end with AT, ferrate. And oxidation number here, it is 2. And you know how to find the oxidation number, I told you. All right. So first you have to name the ligand, followed by the central metal. So prefixes, you know, what is that prefixes? Di, tri, tetra. For a special type of ligands, you'll give bis, tris, I gave you all this. Now, if you are talking about a polynuclear complex, what do you mean by polynuclear complex? We have not taken any example with polynuclear complexes. Polynuclear complexes, the bridging group is indicated by the formula of the complex, separating it. Now, for an example, if I have two cobalt atoms, these are bridged by a ligand here, OH. So when they are bridged by a ligand OH, then you should write the bridging group is indicated in the formula of the complex, separating it from the rest of the complex by an hyphen. In polynuclear complexes, a complex with 2 or more metal atoms, bridging ligand which links 2 metal is denoted by the prefix Mu. Here the bridging ligand is what? Hydroxyl group. Hydroxyl. When you're naming, you have to give it as hydroxo. That is what it means. It's an OH minus ion. It's a negative ligand. So therefore, the name has to end with what? Oh, hydroxo. All right? Hydroxo. All right. Naming the ligand, I told you. Different types of ligand, that is neutral, positive, or negative or positive, are named differently in the compound. Negative ligands, the name has to end with what? O. Negative ligand, the name has to end with O. Positive ligand, the name has to end with IUM. Neutral ligands have special names. Carbon monoxide is named as carbonyl. Nitric oxide is named as nitrosyl. Water is named as aqua. Ammonia is named as amine. All these are special names for neutral complex, aqua, amine, etc. All right, that is what it means, naming the ligands. Different types of ligands are named differently. But it means positive, negative. See, and if the metal is in the anion, see, for some elements, ion named is based on the Latin name of the metal. See, the complex is a negatively charged. The name of the metal has to end with AT. See, if the complex is negatively charged, if you have iron, it has to end with AT. These are Latin names. Silver has to name written as argentate. Tin is tannate. Copper is cuprate. Iron, gold is aurate. Lead is plumbate. So these are all Latin names. You have to know these names in order to name the anionic complex. If it is a cationic complex, the name will remain same. Iron will remain as iron, silver will remain as silver, tin will remain as tin. Only in the anion, the name has to end with AT. All right. Point of attachment, ambidentate ligand, NO2, you have to write it as N, I told you, N nitrito or nitrito N. And here, if we have ONO, you have to write it as nitrito O. We have learned example. Here it is cyanate ion, thiocyanate ion. Here it is linkage through S, therefore we have given it as S. Here it is linkage through nitrogen, therefore it is nitrogen. See, this example is also for ambidentate ligand, SCN minus, thiocyanate ion, SCN minus and NCS minus. Here it is sulfur and here it is nitrogen. Ambidentate ligands. So bridging group, we spoke about bridging group. You can see here, cobalt is there and NH2 is a bridging group. So you write mu amido. And if OH is the bridging group, you write it as mu hydroxo, I told you. And water of crystallization, this I told you the last point. It is wrong here. It is sulfate monohydrate. And here it will be dihydrate. Dihydrate. So these are the rules in naming the coordination compounds. And charge should be written. Charge should be written. All right. The name is one word. The name has to be written in one word without a gap. There should be a gap between cation and anion. Only there should be a gap between cation and anion. All right. So there should not be capital letter also. They say one of the rules says the name of the complete should not, the compound should not start with the capital letter, they say. But some of the textbooks, they have mentioned capital letters also. So these are the rules in naming the IUPAC. All right.
Yes, sir. Thank you, sir.
All right. All right. Madam, I'll stop, ma'am.